Hello everyone. In this video you will be learning about Green's theorems. Green's theorem को जानने से पहले I would suggest to make your concept clear of line integral as well as surface integral. If that is clear, then it will be easy to understand this Green's theorem and उसके questions भी काफ़ी easily you will be able to solve it. So let's start looking at the statement of the theorem, and then we will solve the question on it. So as statement, Green's theorem statement, what does it say? It gives the relationship between the line integral over a closed surface and the double integration over a plane region which is called R, which is bounded by that closed surface C. So if it will be helpful, if it will be easy for you to understand if I will draw the diagram. So here this is the closed surface, which is nothing but one triangle. I have taken it here. So this is nothing but the closed surface. It can be any closed curve, not surface, closed curve. So it can be anything. It can be a circle, it can be triangle, rectangle, whatever it can be. It's a closed curve. So what does Green's theorem says? If you take a line integral along this closed curve, मतलब अगर आप line integral लेते हो इसका along AB, along line BC, along line AC, if you add them, so it will be basically line integral over the closed surface over the closed curve ABC. अगर वो आप लेते हो, so that will be equal, वो किसके साथ equal हो जाएगा, which will be equal to the region, this region which is bounded by this closed curve. इसका डबल इंटीग्रेशन जो R मैंने डिनोट किया है द शेडेड रीजन, उसका अगर हम डबल इंटीग्रेशन लेते हैं वो और लाइन इंटीग्रल अलोंग द क्लोज कर्व, दैट विल बी इक्विवेलेंट, that will be equal. That's what the Green's theorem says that. I repeat again, if we take a line integral along the closed curve, जैसे कि मैंने यहाँ पे बताया कि we take line integral along this closed curve AB, BC और AC के through, and we add them together, that will be equal if we take the double integration of this region R, which is bounded by this closed curve or bounded by this triangle, that both will be equal. That's what the theorem says it. How we mathematically represent it is, यहाँ पे जैसे wherever you will be looking, you will come across this symbol that is telling it's a closed curve, integration along the closed curve. So this left and right sides, what does it say? Integration, line integration along the closed curve, mdx plus ndy. Mdx, m and n are nothing but the functions in terms of x and y. So ये left hand side जो बता रही है वो line integral के बारे में बता रही है, line integral along a closed curve. And the right hand side, what it will be telling it is double integration of the region bounded by that closed curve. So double integration, this is the R, nothing but the region bounded in between the closed curve. तो वो कैसे लेंगे, del n upon del x minus del m by del y with respect to x and dx dy. So this is what the it's a statement and how we represent, I mean mathematically we represent it. So now let's solve question which is based on this. So use Green's theorem to evaluate the integration x y dx plus x square y cube dy, where C is nothing but the triangle with vertices. यहाँ पे closed curve जो दिया हुआ है वो triangle है, उसके vertices यहाँ पे दिए हैं 0 0 1 0 1 2 with positive orientation. Orientation is nothing but it tells the direction whether it is clockwise or it is anti-clockwise direction. So यहाँ पे दी जा चुकी है वो पॉजिटिव ओरिएंटेशन है. पॉजिटिव मतलब एंटी क्लॉकवाइज ओरिएंटेशन जो भी होगी वो पॉजिटिव ओरिएंटेशन वी टेक इट. So that is given to you. So from the question, if you take this vertices of a triangle, by using those vertices I plotted the triangle 0 0 जो कि ये origin 1 and this one, and this is 1 2 point which is the C point over here. So by using those coordinates I have plotted this triangle Now what we have to do it, we have to find the line integral along this closed curve. So that will be giving you the left hand side of the Green's theorem. So first of all, we sketched the curve by using the information given in the question. इसका एंटी क्लॉकवाइज पॉजिटिव ओरिएंटेशन बताया, सो एंटी क्लॉकवाइज दिस एरोज आई हैव पुट इट ओवर देयर, जो यहाँ पे मार्क किए हुए हैं. ओके, सो नाउ इफ़ यू सी हियर द एक्स वैल्यू इज रेंजिंग बिटवीन 0 to 1. यहाँ पे 1 0 है, यहाँ पे 1 है एक्स कोऑर्डिनेट. सो एक्स वैल्यू इज चेंजिंग थ्रू 0 to 1. सेम वे y की वैल्यू कहाँ चेंज हो रही है, यहाँ पे इस लाइन का इक्वेशन होगा y इज इक्वल टू 2x. इफ़ यू फाइंड द इक्वेशन दैट्स इज व्हाट इट विल बिकम. सो y वैल्यू इज, यहाँ पे y की वैल्यू 0 है, यहाँ पे y की वैल्यू जो है 2 है, मीन्स 2x है, बिकॉज इट इज़ टचिंग टू दिस लाइन वेयर द y इज इक्वल टू 2x. So now from the equation, from the question, m's value is xy and n's value is x square. See, this is a given thing. Whatever coming with a dx, that is nothing but m, and what is coming along with dy, that is nothing but n. So from the given thing, from given function, we have received the value of mn, which I have wrote it here. M is equal to dx and n is equal to x square y cube. वो दिया जा चुका है हमें. Now we will start finding the line integral over that closed triangle. So first of all we write the Green's theorem as it is. यहाँ पे मैंने जो theorem है वैसे ही लिख दिया है. Now we will start taking LHS and RHS and we will see that both should give us same answer. Both should be equal. So first LHS से left hand side से start करते हैं. Left hand side we will be first taking the line integral. So let's start taking line integral along the closed curve m dx plus n dy. सबसे पहले जैसे कि ये triangle दिया हुआ है, so for each along the each side of the triangle we will be taking the integration. So AB के along, then BC के along and then side CA के along we will be taking the integration. Diagram एक बार आपको समझ लेंगे. AB के along the BC and CA. Along each side of the triangle we will take the integration separately and we will add them together to get the line integral over the closed curve. So वो यहाँ पे मैंने वही लिखा है. Now for each of this thing, if each of this side we will be taking integration separately. So now first of all I will go for line AB. AB line जो है ये तो x axis है, पता चल रहा है आपको डायग्राम से. So x axis का इक्वेशन होता है y is equal to 0. So AB का इक्वेशन है line y is equal to 0. If you differentiate it, dy is equal to, obviously it will be 0, and it's changing from 0 0 to 0 1. So now if you take the integration, जैसे कि m dx उसका integration of, if you take it, it will be 0 because m dx plus n dy, if you take it, it will be 0 because x y की वैल्यू 0 है और dy की वैल्यू भी 0 है. So that's why it will be coming 0. Now we will start with line BC. We will take the integration along line BC. BC, if you look at this diagram it will be more easy. BC, if you look at this line, what is the equation of this line is, it's passing through x is equal to 1, so that's why it is parallel line to y axis. This equation will be x is equal to 1. तो x is equal to 1 value हमने ले ली है, that's why. And if you differentiate it, dx will be 0 and the points is from b0, b के coordinates 1 0 and c के coordinates 1 and 2 are there. So from the, I have written here m and n values so that we can understand this easily. So what we do it, m dx plus n dy we do it, right. So n dy, so m की वैल्यू जो x y है with respect to dx we will differentiate it and x की वैल्यू जो दी है 1 है, dx की वैल्यू x y and this dx plus y की वैल्यू जो है x square y cube and with respect to dy we will be differentiating. dx की वैल्यू यहाँ पे 0 है, so this total term will become 0 and this will be coming 3x square y square. Okay, this first term will become 0 here, and here x value is 1 given over here, so here it will be 1 into y cube, इसको एलिमिनेट करते हैं, 1 into y cube into dy. y cube का इंटीग्रेशन हमें करना पड़ेगा जो कि मैंने यहाँ पे लिखा हुआ है. Now y cube integration will be y raised to 4 upon 4 and upper limit lower limit हम substitute करेंगे उसके साथ. So after simplification we got it as 4. So line integral along line BC we got it as 4. Similarly what we can do it along line CA. हमने अभी तक लाइन AB के अक्रॉस along AB हमने निकाला लाइन इंटीग्रल, BC के along भी हमने निकाल दिया. So what we can do it, similarly you can find the integration along this line CA also and we will add them together. तो हमें मिल जाएगा लाइन इंटीग्रल along the closed curve C. So उसको हम मैंने नहीं निकाला है लाइन CA का इंटीग्रेट along CA का, that you can do it and see how much you get it. अगर आप उस तीनों इंटीग्रेशन को लाइन इंटीग्रल को आप ऐड करते हो तो आपको मिल जाएगा 2/3 विच इज़ नथिंग बट लेफ्ट हैंड साइड वी गॉट इट. नाउ हम सॉल्व करते हैं ग्रीन्स थ्योरम की राइट हैंड साइड को. राइट हैंड साइड क्या कहता है कि वी हैव टू टेक अ डबल इंटीग्रेशन ऑफ द रीजन विच विल बी बाउंडेड बिटवीन द क्लोज कर्व. सो उसका डबल इंटीग्रेशन हमें लेना है. सो नाउ इफ़ यू remember this right hand side, I have written over here for your understanding. So from Green's theorems, this is the right hand side of the Green's theorem where it's a double integration over the region R, which is del n upon del x minus del m by del y, and double integration लेंगे dx dy के साथ. m की वैल्यू और n की वैल्यू भी मैंने यहाँ पे लिख दी है. So that now so if you try to do this like यहाँ पे n की वैल्यू विथ रिस्पेक्ट टू x अगर हम करते हैं, मतलब x स्क्वायर y क्यूब को हम विथ रिस्पेक्ट टू dx with respect to dx if we will differentiate it, and similarly m को मतलब x and y को m की वैल्यू जो दी जा चुकी है वो है x y, इसको डिफरेंशिएट करेंगे विथ रिस्पेक्ट टू y. So then what you will get here is 3x, sorry, it will be 2x y cube, and इसको अगर डिफरेंशिएट करते हैं विथ रिस्पेक्ट टू y तो आ जाएगा वो x. So this is what we will get it, और वो मैंने यहाँ पे लिख दिया है, and that we have to differentiate, we have to again integrate with respect to x and y. So उसके साथ ही हमें डबल इंटीग्रेशन निकालना है, तो ऑब्वियसली एक्स वाई के साथ निकालना है, तो हमें एक्स और वाई की लिमिट्स भी हमें it is we need to take that. So if you look at here, x is changing from 0 to 1 यहाँ पे, और y की वैल्यू हमें मतलब 0 to 2x it is changing. If I will take any strip over here, let's say, so if this is the strip I have taken just to understand u limits. So अगर इस strip को हम वेरी करते हैं, मतलब मूव करते हैं from along horizontally, तो यहाँ से 0 से 1 तक चली जाएगी. If you see lower end of this strip is at 0 and upper end is touching to the line, which equation is y is equal to 2x. इसलिए y के लिमिट्स हमारे बन जाते हैं 0 to 2x और x के लिमिट हो जाते हैं 0 to 1. We need that because we have to substitute the upper limit as well as lower limit. Now start differentiating. First I have start integrating. First of all I have integrated with respect to y. तो इसका इंटीग्रेट करने के बाद हमें मिल जाएगा x y raised to 4 upon 2, और x का इंटीग्रेशन x will be constant और it will be outside and it will be y x y. So now start putting upper limit lower limit. So जहाँ पे भी y है उसकी जगह, जैसे कि यहाँ पे y की जगह 2x हम लिखेंगे, 2x upper limit है. Same way here also 2x, तो हम y की जगह 2x रख दिया यहाँ पे. So after simplification we will get lower limit रखने के बाद obviously we will get 0. I didn't write it over here. Now after simplification you will get this 8x raised to 5 minus 2x square. अब हम इसको इंटीग्रेट करेंगे विद रिस्पेक्ट टू x और उसके बाद उसमें अपर लिमिट और लोअर लिमिट वी विल सब्स्टिट्यूट. So after doing this I got this one after taking the integration. So now simply I will put upper limit as well as lower limit. So x जहाँ पे भी है मुझे upper limit जो 1 है substitute कर दिया मैंने यहाँ पे, lower limit लगने के बाद 0 आ जाएगा. Now simplify it. So you will get after subtraction, after simplifying we are getting 2/3. अगर आपको याद है वहाँ पे लेफ्ट हैंड साइड में भी मुझे 2/3 मिला था आफ्टर फाइंडिंग द लाइन इंटीग्रल ओवर द क्लोज सरफेस. और यहाँ पे मैंने इंटीग्रेशन डबल इंटीग्रेशन लिया हुआ है ऑन द ओवर द क्लोज रीजन विच इज़ आर बाउंडेड बिटवीन द क्लोज कर्व. सो उसका डबल इंटीग्रेशन की भी वैल्यू मुझे 2/3 मिल रही है. So this is how the Green's theorem is getting verified, क्योंकि that's what the Green's theorem says, that line integral over the closed surface is equal to double integration over the region bounded by the closed curve. तो हमें यहाँ पे दो LHS is getting equivalent to the RHS, and this is how we are this Green theorem is getting verified over here. So if you understand it like same concept, मतलब अगर हमें line integral अच्छी तरह से आता है so that will be quite helpful, because left hand side में तो हम वही कर रहे हैं, same like how we did find line integral over the closed surface का हमने किया था, वही कर रहे हैं हम यहाँ पे. और RHS में हम इसका डबल इंटीग्रेशन ले रहे हैं. तो लाइन इंटीग्रल आपको कंसेप्ट क्लियर है तो ये 3 ग्रीन्स थ्योरम क्वेश्चन करना काफ़ी ईजी रहेगा. ओनली थिंग इज यू हैव टू अंडरस्टैंड द स्टेटमेंट, द गिवन इक्वेशन ऑफ कर्व, और बेसिक इंटीग्रेशन का कंसेप्ट अगर क्लियर है तो देन इट्स क्वाइट ईजी. सिर्फ ये थ्योरम मैथमेटिकली जो उसका स्टेटमेंट है वो याद आपको रखना होगा. इफ़ यू कुड इज able to remember this, write it properly, then I think you should be able to solve any question on the Green theorem. Thank you.